Last time I promised to show you new areas in the game. Most of my time went into implementing a puzzle involving this firefly swarm. Well, they aren't really fireflies, more like firefly, bee, butterfly hybrids. You see, if Amy gets close to them, they start following her around. I've learned some really cool stuff about Niagara particle systems in Unreal, which I'd like to share. In particular, how you can pass data around between the emitters in the particle system and between the particle system and your game logic in Blueprint. So let's dive straight into the technical section. Let's pause this for a moment. So this particle here, I'm gonna call it the queen, because my fireflies have queens, is following Amy. And these over here, that's another emitter, and I'm gonna call it the swarm, is loosely following the queen. You don't really see it here, but there's also a dynamic light source that is positioned with the swarm and following the swarm around. So let's do this little bulb. And finally, there's some additional Blueprint logic controlling the particle system. So for example, there's a trigger volume placed roughly in this area that starts the following behavior when Amy intersects it. As you see, there needs to be a lot of communication between all these parts. On a high level, this looks like this. We have our Niagara system here, and it contains an emitter for the queen. This would be just one particle. And another emitter for the swarm. Then outside the system, we have the game logic. There's Amy and other stuff generally in Blueprint. Now all of these live in their own little boxes, right? There's the particle system as a whole, the two emitters in that system, and finally the game logic in the Blueprint world. Now we need to let the swarm know where the queen is, so we have to pass particle data from one emitter to another emitter. We need to let the Blueprint logic know where the swarm particles are, so we have to pass particle data from this emitter to the Blueprint. And finally, the Blueprint logic wants to control the particle system in a number of ways, so we generally want to pass parameters into the system. For these three use cases, Unreal provides three different mechanisms. To pass particle data from one emitter to another emitter, there's something called events. To pass data from an emitter into the Blueprint game logic, there's something called the particle data export interface, long name. And finally, perhaps the simplest of all of these is the parameter passing, which can be done with user parameters. Now let's have a look at the Niagara system inside Unreal. It contains one emitter for the queen firefly, which is just one particle, and another emitter for the swarm. These are around 100 particles. I won't go into the details of how these are set up, because I just want to focus on the communication between these parts. To let the swarm follow the queen, I set up a generate location event module here in the particle update section. It should be placed right after the solve forces and velocity module to make sure that the particle data is accurate. As you see here, you can specify a send rate with the event, which can be a nice optimization if you don't need to send particle data around the system at every frame. So here I'm just doing it 5 times per second, which is enough. Now the event has been generated and is being sent, but we need to receive and handle it somewhere, right? In the emitter for the swarm, there's a whole stage for handling events. You can create one here with adding a new stage. You can choose the source of the event from the properties section. Here, that would be our queen firefly, and it's a location event. In the receive location event section, all the data is listed that is passed along with the event. What I've done here is copying the received position data into a custom variable that is going to be used in other places in the emitter logic. In particular, it's going to be used in the particle update section to generate a force attracting the swarm towards that point. In the list, you can see the names of the data elements that you can use when you want to assign that data to other variables. Like here, I've copied the vector1 element into my attractor position variable. If we want to do the same for, say, the velocity, we can look it up, it's vector2. Let's add a new section to set a new or existing parameter. And here we add the parameter, just select make new, and it's a vector. And we know the velocity is in vector2, and that's it. Now let's look at how to communicate with the blueprints. Getting data from the blueprint into the particle system is really easy. There's something called user parameters, as I've mentioned. They are listed down here in the user exposed area. I've added a few here. For example, this attractor position is basically Amy's position in the world. You can create arbitrary new parameters by using the plus button here and choosing between the available types. Once defined, you can use it in your emitter logic like any other attribute. Of course, we want to set the values of these parameters from Blueprint. Let's have a look. This is as easy as it can get. There is the set Niagara variable node, where you just need to make sure that you pick the correct variant for the type of the user parameter you've created. And also you need to type in the variable name as text here. So you better make sure you don't introduce a typo here. And that leaves us with the possibly most difficult part of all of this, the particle data export interface. That will be used to send particle data from an emitter into our blueprint logic, where we can do whatever we want with it. On the blueprint side, we need to implement the receive particle data interface. You do this by going to the class settings, look up the interfaces section, and in implemented interfaces, you can just add the interface that you're looking for. When you right-click this, you would see an implement event context menu entry, which doesn't show up here because I've already implemented it. The event is then called regularly, where the particle data is packaged into an array with one struct for each particle. Now we've got to let the Niagara particle system know that we have implemented this interface and want to receive the data. You do this by adding an export particle data to blueprint module to your emitter. There are a number of parameters to modify the behavior of this. So for example, there's a conditional flag that you can use to toggle the particle data export on only when you need it. There's a delay to reduce the frequency at which the event is going to be called. And of course, there are the parameters that are going to be sent with the event, and you just link those to the particle attributes that you want to receive in the blueprint. This can actually be anything, so the struct has named parameters, position, velocity, and size, but you can stuff anything you want in there. And finally, there's this entry here, which sets up the connection to the blueprint interface. The way this works is you add a user parameter of type object, which you plug in here. In the blueprint, you use the set Niagara variable node again with a variable of type object, where you just pass self, that is the object that has implemented the receive particle data interface, into the variable of the name you gave it. Now there's one detail I want to mention, because it had cost me hours of trying to figure out why the heck it wouldn't work. So you might be tempted to say, okay, I need a user parameter for the callback, so I just go in here, say make new user parameter, which is going to be this one. And I rename it to my export callback and use that from blueprint. This is not going to work. Don't do this. You have to create a new user parameter, and it has to be of type object. It's not of the export particle data interface type. Instead, you choose object, and that's going to be your parameter. And you select that into the callback handler parameter field. There's actually a nice working demonstration of this mechanism in the content examples project that you can download from the Epic Games Marketplace. I unfortunately only learned about this after digging around the internet for hours trying to find out the information I needed. This would have been a real time saver. When you have opened the content examples project, go to Maps, look for the Niagara Advanced level, and when that is loaded, you find the example for the export data interface at the very end of the hallway. If you open the blueprint, you find a very nicely documented implementation of the interface that I've been describing. And that's all I have for today. Hope it has been useful. Have fun implementing your own particle systems, and see you soon. Bye.